Hi, Nestor.
Hi, Pitt. How you doing?
Doing well, thanks. What about you?
Good. Yeah, I'm very good.
Excellent.
Well, we will start with our problem. I have two problems right here. So
Okay.
both of these are easy. So, but there's no problem if you only accomplish one.
Okay.
So, which language you going to use?
I'm going to use Swift, my main language.
Okay.
Where is it? Oh, it's here. There you go. Okay. Should I start?
The problem is this. We were going to give you a list of numbers. These only numbers, and a number k. You have to return a list of pairs indexes of values that sums k. I'll give you an example. I don't know if you know this problem, but there is. Let's say if I give you a key 13, you have to find the pointers of the elements that sums 13, like 8 and 5 will sum 13. The addition is 13. So the index is 0 and 2. And 3 and 10, the result is 13. And then the indexes are 1 and 5. We're looking at a pair of indexes that after the operation will give me the k number.
Okay. Okay, makes sense. All right. So first question here: what is the minimum length for the array? Is always greater than 0, or we could expect 0?
It's always greater than 0 in the first attempt. It will be only more greater than 2 the length.
Okay. Okay.
Or at least 2 elements.
At least 2 elements. Okay. 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 What will happen if we don't get a valid sum for the key value, for the k value?
Oh, so you don't have any pair, so you need to return
an empty array?
Empty array or null or whatever. Yeah, an empty array will work fine.
Okay. Okay, great. All right. Okay. What could be the logic here? Yeah, obviously, the most naive approach is creating an iteration for every single value here, and then another inner loop to check. Checking the first elements against the rest, then the second one against the rest, and so on, right? And then if we found that the element AE and AJ, for example, are equal to the k value, so we can assume that we got the answer, right? However, that algorithm will have a complexity time of O(n) squared, right? Because we have to basically have a square time, because we are manipulating the same element, the same array in 2 dimensions. So I think could be definitely a better way. Like, for example, I think that the best solution here should be O(n), just one pass for every value, right? But I think we could see here. I'm just checking what approach could get here. Let me think. For example, obviously the key value, well, the point here basically is that for every element in our array, right?
Yep.
Every element, well, A minus a specific A element, we should return us the other elements. So this is basically referring to the first iteration when we talked earlier. We try to find if we get basically the I element plus the J element equal to K, right? But in this case, I'm trying to think in the opposite way, right? So having K and having K, we could, for example, I'm just thinking, for example, we could do a first iteration. Get well, and also creating a hash table.
Okay.
Where we could establish the relation between what is exactly the value from every element here, right? So, for example, if we have in the first element A0, right? This is zero. This is 0. Yeah. This is in this case is equal to 8, right?
Yeah.
But following the approach of K, which K is 13, so 13 minus 8 is equal to 5, right?
Yeah.
Right. So in this case, we could have a dictionary, well, which is called in iOS, in Swift, sorry. We could get that for the 8 value. We could have, well, an association that we need to find this element, right?
Okay.
And the next one, we could also add another element, in this case 3. 3 will be related to 10 in this case, right? After the operations, right? And so on, right? And then having a second iteration where we actually looked for those elements, right? So in this case, we could get I'm just thinking that this is going to work in terms of the complexity. So what I'm looking here is with a second iteration trying to find those elements, but I'm thinking maybe doing the opposite. Not sure if this.
What do you mean with the opposite?
Instead of in this case, for example, we have a key like the element we know, right? And this and the value here is the expected value, right? So this value could not be here, could not be in the array, right? Because we're trying to find it, right? So right. So yeah, because if we do an iteration, we're going to get the same. I mean, we are looking for this key that we actually know that it's in the array, right?
Oh, okay.
Yeah. But the point here, I think I would do the opposite. Instead of creating the array in that way, I will use the expected value as a key, and the value that we know already has the actual value, right? So in this case, we are looking for 3. I will add another example. For example, I will get 9, right? 9. So to get 13 is 4, right? We know in this case that 4 doesn't exist, so right? Okay. No, it's the opposite. Sorry, it's 4.
Oh
and 9, right?
Yes.
All right. So basically, now what we have to do is checking in this algorithm, checking if hash map contains a element, right? If it's contained,
okay,
then
the key.
Exactly.
Contains the key.
Yeah,
Okay.
if that contains a key, so we know that we have elements with the located in the array to do the operation. What I'm looking here is that I need the other index value, right? So for example, here I know that I know the first part, which is the element A, right? But I need the J value. Okay, so I think in the first iteration I need to create what I can do. Oh, okay. I know. Instead of loading the actual value we already know, why not using the actual index, right? So the hash map in this case will be something like this: expected value.
Yep.
And this one will be index of the already.
Yeah.
So instead of A, we're gonna save a 0. In this case, we're gonna save 1. And this case, for example, we're gonna say 1, 2, 3, right? So we know that the value is the index. So this will make us very easy to find elements. So what we need to do is that if exist, we're gonna create I don't know a new set of elements, an array, like the e-value and the dictionary. This just format this of AE. Does that make sense? Because this is the key. This is the key.
That's the key. Yeah, for sure. Yeah.
Because we know for sure that key exists. So we're going to create this pair of values.
Oh yeah.
Make sense?
That makes sense.
I think I don't know. Do you think it's a good approach? Could I start coding?
Yeah, it's a good approach, but let me ask about what about if instead use 2 loops? You can do it just with the first iteration.
Let me see. You know, maybe, right? Because, okay.
If there's no answer right now, it's okay. You can go ahead coding. It looks well.
I think I just trying to think. I'm going to try just one iteration. Let me just give the example here. So for example, if we found the first element, that obviously the dictionary, I will set the dictionary here. So the dictionary in this case is empty. So if
Yep.
the first element is, well, obviously the dictionary is not found, so there's nothing else to do. So we're gonna save it. We're gonna save here k minus the element, right?
It's 5.
That is 5, and the index, right? So is 0, right? So let's move on to the next one. And we're gonna check. Okay, is there already existing in the dictionary? No, it's not. It's not found. So what I'm going to check is then I'm going to add it. So I am going to add the remaining of the key of the sum, which is 10, and the index, right? And then the third one, 5. So do we have a value contained in the dictionary? Oh, yes, we found it. So that means we're going to add. Well, we have another result here. We're going to have the index. In this case is 0, 1, 2, right? 2. And we're gonna say the actual value, which is AI, sorry, which is 5, right? No, sorry, which is no, the value of the dictionary, sorry. So let's use this 2 and 0. Does that make sense?
Yeah, that makes sense.
Okay. The ordering it doesn't matter.
Okay. It doesn't matter the format of the pointers. Because it's just switching the pointers. So
okay, makes sense.
You found the pointers. That's
correct. Okay.
What matters.
Okay, so we have our result here. So next move is the third element. So do we have a value? Oops, sorry. Do we have a value for 9? No, we don't have it. So okay, so we're gonna add then here the number 4 because it's the remaining, and we're gonna add number 3 because it's the index, right? So next iteration 6, 13 minus 6 is 7, right? 7 is not existing yet, and number 4, right? Number 4. And finally we have 10. 10. Okay. 10 exists in the array. Yep. Yes, it exists here, right? So so we, instead of adding it, what we're gonna do is add the current index, which is 0, 1, 2, 3, 4, 5, right? Yep. And the actual value contained here, right, which is 1, right? So index 5 and index 1 can resolve in the k elements. Oh yeah, thank you. Yeah, so yeah, that second iteration is obviously redundant, not necessary. So yeah, you can do it in just one array. So we end the loop and we return the result. So I think it's much better, right? So with this approach,
let's go.
Yeah. Okay.
Yeah.
One last thing before coding. Is any restriction about the maximum type of values? For example, in this case we have 13, but could we have here something like 20 or 14, for example?
Okay. Yeah, you can have any kind of numbers.
Okay.
It could be 1 million, but there's only positive numbers.
Only positive numbers. Okay. Okay.
Which it doesn't matter because you maybe will have a negative key. Let's say you have the 20. you will have a key -7.
Exactly. Okay.
So it doesn't matter if it's positive or negative, but it will be only natural numbers or not floating numbers.
I think won't affect the algorithm. Okay. All right, cool. So I'm going to start. How to call it? Pair of and we're going to return actually could be an array of integers, or well, we have also we could use tuples in Swift, which is just another way to use to accommodate elements. But I will keep it simple in this way. An array. We have here an array of int.
Yes.
So now what I'm going to do is just give if array.count is well, just making sure it's greater than 2, and then 1. Otherwise, we're gonna return immediately, right?
Okay.
First statement. So okay, now let's create our result equal like this way, array, and all right, let's do an iteration here. All right, oops, 0 array.count. Also, we have a dictionary which is int of equal to the dictionary. What else? Obviously, we want to return a result here, and what we're gonna do is check if array. Oops, no, dictionary.
Okay.
Dictionary. Oh yeah, of course we need the key value. Okay.
Yeah, the key value. Missed it.
If k, I'm going just to clean the thing here. Value is actually array of. If dictionary k minus value equal to nil, I'm going to add it. Actually, just to keep things simple, let k equal to this. And then k is equal to set. Oh, so is a remaining, right? So is the index. In this case, it will be the index, right? Otherwise, that means we found a value. So result equal to the actual I element and dictionary k, correct?
All right.
And I think that's it. Just I'm going to test it quickly. For example, sorry, going to get these elements here. All right, so quickly, we know that this condition is okay. And then the value is 8, right?
Yep.
So we have the key here is 13 minus 8 is 5. So 5 exists. No, because it's the first one. So we add 5 equal to 1, right? Equal to 0, sorry.
Okay,
right?
Can you simulate your dictionary right here? Okay.
Establish again this 5, 0, right?
Yeah.
And next one. The next one is 3 and index 1. So we have here the key is 10. So a dictionary that with key 10 exists? No, exists. Is not, is empty. So we have to add it. So we have to add 10 and we have to add 1, right?
Yep.
And as movement is 5. So we're gonna get 13 minus 5 is 8. So dictionary wait a second. 8. No, I think I got something here. I had to, the key is actually the value. Yeah.
Yeah.
My bad. It's actually the value here, value, right? So, yeah, it's actually the value. Well, but yeah, but the key is, wait, wait me just 1 second.
Yeah, for sure.
I think I'm doing something wrong here. I will start with the beginning. Yeah, what we are checking is by the key, right? So we have the value, we have the key. I'm going to just double check here if I will clean up this in a moment. If first checking if the value actually exists. If the value exists,
okay.
that means then we have to add the actual result here, not in the other way. Because we found it, right?
Yeah, you found your pair.
Correct. Yeah. Else, in this way, we will have to create this value is okay to be here.
You miss your value.
Exactly. Yeah. Otherwise, we know that the value is not existing here. So in this way, it's okay to create another iteration. Okay, I will just check this again.
Before you start, I think you missed your key. You didn't declare your key.
Yeah, I was trying to.
Okay, that's it.
Okay, so sorry. We have number 8.
Yeah.
Again, dictionary. Well, we don't have anything about number 8. So, yes. And then we're gonna create a key with the actual remaining of 13 again and minus value, right? So in this case, we already have 5 and 0. Yeah.
Yeah.
Then,
for sure.
Then move on to the second iteration. So we have value here. We have 3. Well, no, it's not existing here. And we're gonna create then k minus value. So we're gonna create 10, 1, right? So the next iteration is 5. So 5 exists in this array. Yeah, we got it. So we're gonna add the result, the current index, and the dictionary value, right? Which in this case is 0. Okay. So next one. Do we have 9 here? No. So then we're gonna add the remaining. So let's add 4 and number 3. Next one is 6. 6 is found here? No. So then that means we need to get the remaining, which will be 7, and 4. Okay. And finally, we have to check 10. 10 exists in the dictionary, yes. So we're gonna add the actual index right now and the dictionary value of 10, which is the index, right? And then this is not necessary anymore. So I think this is the result.
Yeah, looks great. It passed your test case. So yeah, for me it works. Looks good. So what's the complexity of the algorithm?
It's basically ON in terms of time, because we are just iterating to the array, right? And those operations are the append, the dictionary checking, etc. are all one. So yeah, it's not affecting the time. In the case of the space, obviously we have it's also not sure if we could get, well, I think the most case for the result could be maybe n divided by 2, because, well, having that all elements could make a match against the current the current result, the current key value. So but they're still being n. So, and also we have the dictionary here that in the worst case could be adding all the dictionary values and then not finding anything. So still being ON. So in space and complexity, and sorry, time and space is so ON.
Yeah, for sure. So let's think about. Let me tell you, there is no edge cases on this problem because you are looking for pairs. But there's one situation. What about if you have repeated values? What about if instead of 6 in your array, you see a 5 again? What will happen in that case? Or instead 9 or 6, you see the number 5 again. How you think this is going to work well? There's no problem because you're looking for your pairs. Here we are again.
Sorry, we had technical issues. Yeah, what I was talking about before the issue is that I think even if we have duplicated values, but those values are in a different index. So what I think is that it's valid to have, but the algorithm is still working because it will only add a new element with a new index, right? So
yeah,
this one will be 0, but in this case will be 3, right? So a difference from 2. So I think it's still working, right?
Oh, still working. Yeah, for sure. Yeah, it's just one case that maybe you didn't think, but it works for sure.
Yeah.
So that's it. That's it. Right. You did it really great. Yeah.
Great, thank you.
achieve the
Cool.
problem. The solution is really good. So, do you have any questions?
No. Well, I just would have what is a good advice for everybody watching this recording that you think will worth it to know in terms of controlling the situation when you are doing interviews like this? Any comment?
I don't get your question.
Yeah, any advice that maybe
any advice for you?
For me and for people watching this video?
Oh, for everyone.
Yeah.
Who can watch this. Any advice of
because most people.
This is my first interview, so I don't know. So this is this is the first time that I do an interview to someone else. So advice will be.
It's okay. I mean,
I have no advice.
No, I mean, for example, well, I just meaning to things like trying to move on, to think loud, because it's the only way to take control of the conversation. Yeah.
You say?
Can you hear me?
Yeah, I can hear you. I would say the only thing that I see right here with you is that you maybe code without thinking loud, but you are coding variables or you are coding declarations. So there's no need to tell me that you are doing, oh, this is the result when I see the name of the variable. So that's it. I used to tell, I'm going to declare my variable result, which have this this type, and this is going to, I'm going to store my result. I used to do that, but that's it. That's the only thing that I can see with you.
Okay.
But
that's perfect.
In the other line of code, you did it very well. You tell me what are you trying to do with those lines. So that's it. It's the only thing. The star, I just say, oh, okay, he's missing to explain me what he's doing. But after when you start with your loop, you did it really great. You explained me everything. You walk me through the solution and your coding. So the advice for those people is try to say everything that you are thinking. I know that you maybe think a little moment for thinking in your head. There's no problem. But while you are coding, you need to walk your interviewer through your code, because you maybe are trying to do something and he doesn't know. That's the only advice for those people that can see this video.
Yeah, that's great. Thank you. Yeah, I would like just to mention that in situations like my situation where you found a bug, don't think, don't stress out. Just try to think loud. That helped me a lot to find that I was using the incorrect key, right? Test your code, because probably you are assumed that okay, everything is working because I just think that in my mind and that's it. No. Try to follow your own formulas like this. For example, I found that the key doing the testing, the key is incorrect because I found that I'm not going to get what I'm expecting, right? So doing that exercise will help you to do a great refactor in your interviews.
Yeah, always taste your code.
Yeah, great.
So that's it.
All right. So, well, thank you, Nestor.
You're welcome. I'm going to stop the recording and we will continue with the call.
Mm-hmm.